store energy. Capacitor does it in the electric field, inductor does it in the magnetic field. And when it stores it, what does it do with it after that? It gives it back. It actually does not consume anything. It returns everything that is given to it in one way, shape, or form. You'll hear more about that in a few minutes. Okay, so that's the big picture I wanted to draw about impedance that Greg didn't cover, but that's my style versus Greg's. Go ahead.
It's easy to picture that a battery stores and delivers, but at some point it dies.
A battery.
There's some dissipation there.
It's not dissipation. It's
not.
Because that's not the load. That's the generator. That is the electromotive force that makes the current flow, as opposed to the resistor, the light bulb, the machine, whatever it is, that the electricity is powering, which dissipates.
Oh, okay, so it's taking.
All right, so what's happening in the batteries, you got some chemical reaction going on. You know, the most common dry cell that you had as a kid was magnesium dioxide, it was a carbon rod. Magnesium dioxide would go through a chemical reaction with the carbon rod, and in doing so, would produce a difference in potential. As the current would flow, the chemistry would go from one chemical to another. Better example is your storage battery in your car. You got these lead plates and you got these lead oxide plates. And then you got a bath of sulfuric acid, and there's a chemical reaction that goes on when you pull current out of it. Both plates, the lead and the lead oxide plates, do a transformation to lead sulfate. And when the lead and the lead oxide are gone, or the plates are totally covered by lead sulfate, the battery's dead. Now you put a charger on there, you reverse the process that goes back from lead sulfate to lead and lead oxide. You're having a chemical reaction take place that's producing a current flow. That's an energy. They say, you put your charger on, you're quote charging the battery. You're not putting charge in the battery, you're putting energy in the battery. The terminology is bad, but that's one thing my college physics teacher told me. He said, you're not charging it, you're putting energy in that damn battery. Okay, I get it. Physics 106. Anyway, that's the electromotive end. Okay, let's go a little bit into these two guys that are very, very fascinating, because this is what's going to make radio come alive for you. When you have a capacitor, you have an inductor, and they're time variant, meaning they really have different characteristics at different frequencies, you have radio. Why? They can filter. They can say, I want to receive WGN on the radio, 720,000 cycles per second of frequency. At some frequency, this and this will interact in such a way that they'll pass current through and block all other frequencies. That's a tuned circuit. That's how you basically select frequencies amongst the whole spectrum that you want to deal with. Beautiful, beautiful stuff. Let's take a quick look at how that happens. And one of the things I didn't talk about in the beginning is this handy dandy handout that I came up with. I should talk about this before I forget. There's some nice little chit chat from American Radio Relay where you can hear about getting up in here and doing great things. Reasons to learn Morse code. I guess the answer is because you're bored. Now, Morse code actually is wonderful, and it's the narrowest kind of signal you can generate. And in doing so, it uses the power of your amplifying equipment most effectively. You get more punch. You can, in the worst propagation conditions, you can get yourself heard around the world with Morse code better than you can with voice, because it's the least complicated signal. It's a very simple piece of radio wave turned on and off with a switch called a telegraph key. The problem with it is it's slow. If you're a good radio telegraph operator, you might be able to copy it 15, 20 words per minute. When I'm speaking to you, I'm speaking to you, especially me, because I babble on so quickly. I can do it 100, 120 words per minute. So basically, it's inefficient in terms of how fast you can get your words across. But that's the trade-off. If you want the convenience and armchair luxury, use voice, and If you want to do something fancy, you use data. You let your computer send data across the air. We do that a lot nowadays. And if you want to try something very simple and very effective, you learn Morse code. It's no longer required for license. It was until 2006, I think, is when they stopped doing it. It's not that it isn't worth learning.
Jay Leno did a test on
And I saw that.
passing Morse code
They had the
versus a text
fastest
message.
texters on the web, and then they had these guys with the sleeve holders and the green eye shades, and they smoked these guys with the texting every time. They sent out using, some electronic here, a message in about 20 words per minute, and it just, rapidly put the message across. And what was the message? Could have saved
More money.
more money in 15 minutes with Geico. If I change my insurance. Yes, I saw that episode, and I even copied it on my computer if anybody wants me to send it. It was a great little thing to say. Jay Leno had the shtick one night where he said, okay, ask the audience anything. Okay, who's going to win this contest? The guys texting on a cell phone or these two telegraphers with ham radio, sending a message from point A to point B? The ham's once, hands down every time. If you want to learn Morse code, I didn't bring it with me tonight, but you can still buy a CD set from the American Radio Relay Lake. One CD in there teaches you the alphabet. It doesn't say A is da-da, B is da-da-da-da, C is da-da-da-da. It says A, da-da, R, da-da-da, E, did, R, da-da, da-da-da-da. In other words, it does it phonically, like you learn in kindergarten how to associate words with sounds. And it works, and if you get through that by having the diligence to learn the alphabet, the second CD, and there's a drill that kind of builds up your speed. And then there's some old FCC exams that are obsolete, where you can actually take the test as if you were taking for the FCC years ago, and they'll give the answer sheet is there so you can check your work. And then if you really feel you're up to speed, get on the air and listen to some of the guys, especially at the low end of 20 meters, nailing it out at like 40, 50 words a minute, see if you can keep up. No, then you find somebody who's slower. But that's how you learn, you practice. It's like everything else. Okay, what else is there? Words, propagation, little thing about how the sunlight affects propagation. If you're getting into this hobby, you're getting in at the right time. We're in the solar max in this 11-year sunspot cycle. And what the sun does with the solar flares and its coronal mass ejections is it sends out these charged particles that thicken the ionosphere, the layer above the Earth that reflects radio waves. It makes it thicker, it makes it smoother, it means your signal not just bounce off the ionosphere, but it'll do it very solidly, even at higher frequencies, like up to 10 meters, which is 28 to 29.7 megahertz. And with a very small amount of power, you can talk to somebody in China. It's amazing how well that works. Consider a frequency operator's guide, meaning certain frequencies are reserved for certain groups that do certain things, so try to not step on them. The bands, these are the frequencies you operate on. Greg said last week, ham radio is the only place where you can actually experiment, build your own equipment. In other radio services, you have to buy type certified radios, like family radios, Citizens Band, commercial products, and so on. Hams can build their own, and they are not given just a frequency, but a whole slice of frequency, which is a band. It starts here and ends there. There's the 80 meter, the 40 meter. The 40 meter band is 7 to 7.3 megahertz. There's sub-bands within it. The low part is for data, CW, any Morse code. The high part is for voice. This you want to study, because this is going to be on the technician test if that's the license you're going for. They're going to ask a few questions about, okay, this band starts and ends on what frequencies? You got to memorize it. There's some things, like on the first test, you don't conceptualize, you just memorize. Sorry, but that's the way it is. The other things, Q signals. You may hear about a QSL card. What's your QTH? It's sort of like Citizens Band radio. What's your 1020? Can you give me a 1036? 1036 is what time is it? Hey, mister, if you can afford A CB, can afford to buy a stinking watch. Uh-huh. Yeah, but it's easier to steal a CB than steal a watch. I've heard that conversation on the air. Q signals are shorthand. Since I said Morse code is hard to use because it's slow, they abbreviate a lot. So these little Q signals can, in 3 letters, ask the whole question. QSL, meaning can you confirm this contact? QSY, slow down, I can't keep up with you. QRT, gotta quit. And on and on, they're all here. No, they're not really on the test, I don't think. How to use repeaters, how to use low band, things that don't use repeaters. The phonetic alphabet. Anybody here ever been in the military? If so, you would understand A is Alpha, B is Bravo, C is Charlie, D is Delta. Hams tend to follow the military phonetic alphabet, picking a word to represent every letter of the alphabet so that if you're in a noisy situation, my name is Rich, Romeo, India, Charlie, Hotel. They can understand those words even if they can't understand the letters. Do you have to know that for the test? Not really, but it's nice to know it. Okay, what else? Yeah, some other abbreviations besides the Q signals, like OB for old boy, and DX for foreign contact, OPR for operator, WX for weather, stuff you'll get used to. The RST system. When people say you are 5 by 9, meaning you are 5, perfectly readable, 9, extremely strong signal. Everybody gets 5 by 9 because they don't want to embarrass you by saying your signal sucks and you're only 3 by 2. But they should. They should be honest. They don't often do that. But that's what that is. There's an RST system. The T part doesn't fit any longer because that's for Morse code. That's the tone quality of your Morse code. Does it warble? Is it scratchy? Or is it nice and solid? Emergency operations. Okay, this is a map of the Flat Earth Society, which is going to have a global meeting next week. All the countries in the world have a letter prefix. Starting in 1925, there was a World Administrative Radio Conference that assigned letters of the alphabet to every country. And countries that came later didn't get letters, they got number letter combinations. If you're in Singapore, it's 9 Victor. By the way, if you fly an airplane in a foreign country, the tail number is always the radio call sign, and the radio call sign always follows the country code. So Mexican airline would begin with XE something. You'll notice that airplanes in the United States always seem to begin with November. And the tail number I was testing last week in Atlanta was November 586 DL for Delta Airlines. We have, you think of W and K because broadcast stations use that W east of the Mississippi, K west of the Mississippi, but there's 4 letters assigned to the United States, W, K, A, and M. A was for Army, N was for Navy. A, we only got the first half of the alphabet. I think Argentina got the other half. So it's explained in the list somewhere. But you'll find some hams have call signs, like Greg last week was N9GL. My call sign is K9RD. It doesn't matter where I am. They just started with W, then gave out K, then N, and then went to A. This will tell you what country uses which. And then a plug for our club. We have repeaters for VHF use. This is where you find them. And beacons. And then this thing. Remember I said that CD set will not give you a chart that says A is da-da, B is da-da-da. So how do you find out what the letters of the alphabet look like in terms of Morse code? You don't find it very often, but I found one and I printed it out for you just so you can look it over for yourself and get used to the idea of what Morse code looks like. Then this thing. What in the world is that all about? 500 spots with a little space next to it. That's how you're going to do your homework, folks. You are going to, after you learn all this stuff and listen to my wise words, take the question pool without looking at the answers and take the test. As I said, the longest test is the extra class test. It's got 40 questions, so the question pool's 400 to 500 questions. Typically 10 times as many questions in the pool as you'll see in any given exam. Put the answers down. Grade yourself. Look up what you got wrong. Learn how to do it. Keep doing that until you get them all right. Then you know you're gonna pass that test. Okay, that's your practice. That's my methodology. That's what I did. Then I got some cheat sheets with all kinds of little things to just look at. Just helpful hints to get you through the test, like what frequencies we use, symbols for various electronic components. This little circle here, for those of you that aren't really good with high school algebra, I'll show you what that's all about. E equals IR is Ohm's law. Voltage, current, resistance. What somebody did was they said, come up with a wheel that looks like this. If you can't remember how to derive, meaning I want to know what current is, so if you divide both sides of the equation by R equals D over R is I, right? This makes it easier. I want to know what E is, so I cover up the E, it's I times R. I want to know what R is, I cover up the R, it's E over I. I want to know what I is, I cover that up, and it's E over R. That's what that's for. So, way to help people that are good at memorizing high school algebra. And some interesting equations like how to add resistors in series and resistors in parallel. Rick talked about that last week. I'm going to go over that a little bit myself because I have something to add to it. All those schematic symbols for resistors, capacitors, transformers, microphones, switches, fuses, you name it. And then finally, the bulletin that I sent everybody for this class, or that they might have found somewhere, and then this is the syllabus. This is important because this is the dates I'm teaching this course, and it's not every week. What's happening is this room, which is owned by the fire department, is used by other community organizations, and I couldn't get 8 consecutive nights. So they said, well, you can't get this night, you can't get that night.